All right, so we're looking at the review for the post-test, that Trig review. It's a single worksheet. It's got some problems on it. I do not have a smart file for it, so we're just going to write some problems down. If you could please look at that first section where it says find the exact value of the trig functions, and they ask you about sine, cosine, tangent, cosecant, secant, and cotangent for both radian and degree measures. So the first question is pretty boring about sine of 240. That's straight off the unit circle. Before we get to that question though, when you're looking at the unit circle ordered pair, someone remind me, the x and y value are representative of what? Cosine of the function and sine of the function. Very good. So if you happen to need tangent, just real quick, remind me, how do you find tangent? Yes, it's y over x, or you can think of it as sine over cosine. And therefore cotangent would be the reciprocal of that. So keep all those in mind. And let's take a look at maybe number 2. So number 2 says, evaluate the secant at negative 60 degrees. So on your unit circle, you're not going to see exactly negative 60 degrees, so you can either trace and find it. You can find the coterminal to that. What is the coterminal angle to negative 60 degrees? If you added 360 to that, you're sitting at 300 degrees, right? What's the ordered pair down here at 300 degrees? Straight off your unit circle, guys. You don't even have to think about it. Yeah, 1/2, comma, negative square root of 3 over 2. So if they want the secant of that angle, secant is the reciprocal buddy to whom? It's to the cosine function. So the reciprocal of 1/2 is 2. So those aren't too bad. And then they throw a tangent at you. Can you look at, how about number 5? I purposely didn't do number 6. Did anybody think ahead why I skipped number 6? Why 6 is significantly easier than number 5? 6 says the tangent of 3 pi over 4. Well, what's the tangent in any of the pi over 4 families? It's going to be twin divided by twin, so it's 1 or -1 depending on which quadrant you're in. So anytime those show up, like that's an easy question. The other ones are the ones that aren't so easy. So tangent at 11 pi over 6. You can read me the ordered pair at 11 pi over 6 directly off of your unit circle. That is the square root of 3 over 2, comma, whoops, negative 1/2. So if I want the tangent of that, you're supposed to take the sine function and divide it by the cosine function, but we're not going to divide, we're going to multiply by the reciprocal of cosine. And then the 2's are going to knock out, and no pre-calc teacher is going to be happy with negative 1 over square root of 3. They're going to expect you to rationalize it. So after a little rationalizing, you get negative square root of 3 over 3. So I was discussing this concept with somebody after school yesterday. And they were basically getting sick of having to calculate tangent and cotangent at the pi over 3 and the pi over 6 families. So I told her what I do to memorize, because I'm with you. It's really annoying to have to keep calculating it once in a while. And when you get to calc, you are supposed to be able to remember like which one is square root of 3 and which one is square root of 3 over 3. So the way I remember it is that the first family, the pi over 6 family, those have the ugly tangents, the ones that are square root of 3 over 3 after you rationalize it. So if that helps you, that's cool. Otherwise, you will have to calculate it every time. So let's take a look at number 7 next on that worksheet. 7 says the cosine of an angle is negative 12 over 13. And then it says the sine is less than 0. So this part right here is just a clue about what quadrant you're in. And when you guys take your post-test and you hit a question that looks a lot like this, the question looks really large because it takes up half of a page, but it's just trying to walk you through it. What quadrant are you in if your cosine is negative and your sine is negative? So this is quadrant 1, 2, 3, and 4. So if cosine and sine are negative, that means you must be down here in quadrant 3. So the best way to approach this question is to draw it. Of course, my triangles are never to scale, but that's okay. So the cosine is negative 12 over 13. And then you have to find this vertical leg because of the follow-up question. So a little Pythagorean theorem. And you will find that this vertical leg is, a lot of kids do this on their calculator, which is fine, but it is a Pythagorean triple. It's a 5. However, because it's a downward vertical leg, I'm going to cheat and call that a negative 5. That way at least my sign is appropriate. They do want you to find all of the remaining trig functions on this worksheet, but what'll happen on the post-test is it's just going to ask you for like tangent. So let's just do tangent real quick. The tangent of that ratio, or of that angle, excuse me, is the ratio -5/12, which is +5/12. I really want you guys to get used to thinking about the appropriateness of your answer with your knowledge of trig. So if you know that you're in quadrant 3 and you just gave me a tangent, well, you better be giving me a positive answer because tangent is positive in quadrant 3. So that's a good way to catch your signs if you're the kind of kid who is a little sloppy with dropping signs like I am. All right, let's take a look at, everyone's favorite, finding solutions. Let's go with number 9 first. It does say find all solutions in radians. So there's no algebra. You're ready to look at your unit circle. And just start with one rotation of the unit circle. Can you tell me where your sine value comes out to -√2/2? Yeah, at 5π/4 and 7π/4. So that's how you would start this question. You would write, well, at 5π/4 and at 7π/4, but because it said all solutions, what extra thing do you have to add to the back of these solutions? You have to include those rotations. Remember what that notation looks like? Plus 2πn is usually how your book classified it. You can use k instead of n, and some of you write plus and minus, but that's the n represents integers, so you don't have to put the minus. These are the questions where sometimes there's an easier way to write the answer, like a more simplified version. But I really highly suggest you guys not worry about that. Frankly, you just don't have time to worry about it, and it's not important to me that you try to come up with a simpler way. All right, take a look down at let's go 13. So same sort of directions, except this time they only want the solutions between 0 and 2π, so you don't have to do that plus and minus 2πn thing. But you will have to do a little teensy amount of algebra before you do any unit circle investigation. So like for instance here, you have to solve for the trig function before you can look at the unit circle. So you divide by 2. So now it says the tangent of theta is the square root of 3. And then if you remembered my little trick I was just rattling off, that's cool. If not, you're going to have to go figure out which radian measure gives you a tangent of square root of 3. And you should be giving me 2 answers because there's 2 places where tangent is positive. So it's this guy up here and this guy down here. What's this guy up here? Is that the π/3 one? And this is where some of you were like, oh man, I'm going to have to calculate tangent every time. That's okay. It's not the end of the world in PreCalc. I will tell you when you move on to Calc, just out of like sheer numeracy of the amount of problems you're given, you're going to want to find a shortcut. Okay? So this is π/3. This guy down here is 4π/3. Oops, that's a pi. So those are your 2 solutions, 4π/3 and π/3. This is a good example of if I asked you for all solutions, this is one that has a very nice shortcut to it, but they didn't ask me for all solutions, so we will move on. Flip to the back of that worksheet, and then we have those horrible U substitution questions that no one likes. So the good news is, let's do number 17. The good news is we have the directions set up to find all solutions, which is good news. That's easier. Do you remember these questions are the ones where if I then make you come back and find all solutions between 0 and 2π, you have like another set of steps you have to go through. So we're not going to ask you to do that on the post test. So this one is all ready to set up at least. But instead of theta inside of sine, it has 4 theta. So we say, forget that. Let's call this a U. And I want you to look through your unit circle only through one rotation and tell me where the sine comes out to -1/2. There should be 2 places where that happens. 7π/6 and 5π/6 and π/6. Say it again. 11π/6. I was like, that is not negative. There we go. Now all solutions indicates you put that plus 2πn on the end of it. And this would be fantastic if we actually had a solution for theta, but we don't have theta right now, we have u. So you need to come back to the beginning here and say, okay, not u, but 4 theta. So then to solve for theta, you got one more little algebra step. You could either think about dividing everybody by a 4, which means you sneak a 4 into all the denominators, or some of you write this as multiply everything by a 1/4. So I'm a fan of sneaking 4s into all the denominators. This top one here, after you simplify, this becomes 7 pi over 24. And then 2 pi n over 4 is going to reduce to pi n over 2. Some of you on that test, it's been many months, but some of you on that test wrote it as 1/2 pi n, and that's okay. And then down here we have similar idea. We have 11 pi over 24. And then same thing, plus pi n over 2. So that's what your solutions are going to look like on that section. This worksheet kind of progresses in difficulty, if you haven't noticed so far. Take a look then at the bottom section. 21 to 30 is all about using your inverse trig function unit circle. So that you will not have access to during your post-test. So you have to remember this. Do you remember where arcsine is defined and also where it's the same place where arctan is defined? Which quadrants? Yeah, down here up to here. And it was very particular in the way we named that. We had to call this negative pi over 2 to pi over 2. But our cosine had a different restriction. What was our cosine defined at? Yeah, just from 0 to pi. So this got a little tricky when we started looking at the unit circle and remembering that if we were down in this quadrant, we have to name the angles appropriately. Alright, so some of the questions are just very direct ones where you're just looking at your unit circle. Like for instance, number 21. It says arcsine 1. They're asking you, if you look on the unit circle where arcsine is defined, where do you get a sine function of 1? And you tell me, where do you get a sine function of 1? Is that pi over 2? Very good. So let's look at something that's a little trickier, like number 25. This one says arctan, which is always trickier, of negative square root of 3 over 3. So first of all, you have to remember where arctan is defined, and now you have to figure out which one would give you a tangent ratio of square root of 3 over 3. So that's the ugly one, if you want to think of it that way. So when tangent's ugly, you're in the pi over 6 family. So you're talking about this angle right here. But what do we call this? Can we call it 11 pi over 6? No, because my calculator would say it's not defined at 11 pi over 6. So we got to call this negative pi over 6. And that was the tricky part to some of those questions. So make sure that we're calling the angle appropriate names for the inverse functions. Then they're going to give you something like a composition question, like on 27. So 27 says arc cosine applied to the tangent of pi over 4. So this one's kind of a combo problem. You start on the inside, and this is just a direct evaluation question. So it says, what is the tangent at pi over 4? Well, you tell me, what is the tangent at pi over 4? That's a nice number 1, right? If you put square root of 2 over 2 divided by square root of 2 over 2, you just get a 1. So now the question says arc cosine of 1. So where arc cosine is defined, where is cosine coming out to a 1? And that would be at 0. Very good. So if it's composition, you have to be careful. Like part of it might be an inverse function and part of it might be direct. And then one more question there. Let's talk about, how about 29? So 29, they have composition again. But this time it's cosine applied to an arctan 12 over 5. So this inside piece is not something I'm going to find on my unit circle, but it is something that I could draw. So just assume that we're in the first quadrant because that's where arctan will come out positive. And I'm going to draw what is bound to be a very horrible triangle that's not at all appropriate for size. But the tangent ratio is 12 over 5. So you're going to set up your opposite leg or your vertical leg to be 12, your horizontal leg to be 5, And then you'd have to do a little Pythagorean theorem to find the hypotenuse, or just remember that that's a 5, 12, 13, which is a Pythagorean triple. So now it says, go ahead and find the cosine of that same angle. So the cosine being adjacent over hypotenuse, or x over r, so 5 over 13. It's all coming back to you now, right? Ah, yes. Unit circles, we love them. All right, so good news. We have plenty of time, guys. You want to start looking at the review for part 1? Yes. All right, so you do get formula sheets. I will give you brand new formula sheets on the day of the test, so you don't have to go like looking through your bag for them. However, you probably want to find them as you're practicing. The only one we're going to probably need today is that salmon trig one. It's a full-size salmony orange color. Yeah, that one. And we were trying to be really, really transparent for you guys. We're very understanding that you guys have a lot of tests going on in the next few weeks. So we don't want you studying extra stuff, and we don't want you studying the wrong things. So this review packet is basically a close related cousin to your post-test. It's in the exact order, has the same sort of rigor to it. Did we discuss where day 1 ends already? 14, yeah. So 1 through 14 is day 1. That's the, I don't know how to classify it, but the older trig, I guess, and then the newer trig shows up at the beginning of day 2. And some of you were commenting that it doesn't feel like very even. It feels like day 1 is lighter than day 2, and I think you won't find that's the case. Day 1 are the kind of problems that typically take you guys a little longer to finagle through. Plus day 2 is a lot of the newer stuff, the sequences. So by nature of it being closer to your memory, I think you'll go a little faster on that stuff than you think. Plus the conics are in day 2, and everybody loves conic problems. You don't look excited. Okay. Well, at least you can focus on conics just for one day. All right, let's talk oh boy, everyone's favorite question. But you have a formula, right? What's your arc length formula? It's at the top of your formula sheet. Do you see it? Which one was arc length? Well, if you don't remember, it says it right there. S equals r theta. It's such a nice little formula, but what's the trick here, guys? Talk to me about my theta. Has to be in radians. In order to use this nice formula, you have to agree to use a radian measure for your angles. So S equals r theta is the formula. The radius of the circle is 11. The problem comes with the theta, because right now it says it's an angle of 80 degrees, but that's not radians. So since they want a weird decimal answer, I would just crank everything in your calculator at once. But what are you going to use as a conversion factor to take degrees to radians? This you do have to know. I would just do pi over 180. You could say 2 pi over 360, but pi over 180 is the simpler version of that. So crank all that in the calculator. It does say round to the nearest tenth. If you happen to give me a pi in terms of pi answer, you're not wrong. But what I have found is that sometimes kids who are trying to answer in terms of pi forget that they're doing it in terms of pi, and then they don't write down pi. So that's a problem. What does this come out to, though? It's 15.4. Awesome. And then it does say you must label. What's our label on this arc length? It's a piece of the perimeter of your circle, so it should have the same label as your radius. All right, this next one. Good time. Linear velocity. So the linear velocity formula that we like to use is r times omega, where it's the radius times the angular velocity. But again, the angular velocity has to be in radians, and we don't have that yet because the only angular speed that they gave you was in rotations per minute. So the first thing you're going to need to do for me is to take your 4,000 rotations per minute, and I need you to convert that to radians. So 1 rotation is how many radians? 2 pi radians. Very good. It doesn't say anywhere in my problem like I have to have it converted to seconds or hours, or I don't have to do any further conversions. I don't have to change centimeters to anything. So this should be a pretty straightforward question. I will warn you, the answer is going to be pretty large and in charge because we're going to answer in centimeters per minute. So that's a lot of centimeters. So some kids are like, well, can I convert it to per second? And yeah, the answer is yes. My question is, why would you want to do that? That seems like more work and you might get it wrong, but whatever. So this is going to be your angular velocity, which you are going, whatever this comes out to, which I would just write as 8,000 pi for now. And then multiply it by your r, which I lost it. It's 5 centimeters. So on your calculator, you've got 5 centimeters times 8,000 pi. Crank everything in the calculator, even the pi, because it does say round to the nearest tenth. And you get 125,663.7. And then label, this is the most important part, guys. You are measuring this, it's speed, so it's centimeters per, I think it's minutes, right? Yeah, per minute. Make sure that you, did I get all my digits? All right. Make sure that you have that label there. If the label is missing, it's wrong, which brings up another discussion we've talked about. So remember your post-test last semester? Very similar in this semester where it's graded traditionally. So there's this many questions on there, and every time you do something, it's worth a point. And if you don't do it right, you lose the point. Like there's no, oh, you're so close. No, you just lose a point. So you need to do whatever it asks. So if it says, show your work here, explain your work here, everything you do on that test is a point. I do have some form of a rubric where, like, if there's a question coming up that there's a very costly mistake that happens in step 1, but if you execute it, like, properly throughout the rest of the question, you still get those remaining points because you did everything else right. But you guys gotta kind of shift your thinking. I know sometimes when you take a test from me, you're like, oh, this is going to be a 3. And that means something different, like if you're grading traditionally. If you're messing up one question and you're messing it up a lot, you're going to miss a lot of points. So be careful. All right. Number 3, let theta be an angle in standard position. They told you a little ordered pair here, and this is us leading you through the question. You have to sketch this, okay? If you don't sketch this and you're not in the right quadrant, you're going to get it wrong. So speaking of quadrants, where are we? Negative 512 would be over here in 2. Very good. Whoop, that's not straight. Okay, so negative 512. And then I don't know why this Pythagorean triple keeps showing up today, but it is. So 5, 12, 13 would be your radius length. We're in quadrant 2, and they want the cosecant. So first of all, should I be getting a positive or negative value for a cosecant in quadrant 2? Should be positive, because sine is positive, which means cosecant is positive. So what is the cosecant ratio? It's the reciprocal of sine, so that would be 13 over 12. Okay. There is a little bit of trig formula, like the reciprocal stuff on your formula sheet, but all it tells you is that cosecant is 1 over sine, so you still have to remember how to find sine, cosine, and tangent. I think we're there. I think you all know that. This next one is a direct off of your unit circle question. So go look at 5 pi over 3 and tell me what ordered pair you're getting at 5 pi over 3. Is this the 1/2 comma negative square root of 3 over 2 ordered pair? Okay. So you can either manually find cotangent right now, or maybe you remember a shortcut, but be careful, this is cotangent this time. How do you find cotangent? Yes, it's the cosine divided by sine. So the cosine is 1/2, and then instead of divided by sine, let's multiply by the reciprocal. So 2's are gone, and then after you do a little rationalizing, I want to see the answer of negative square root of 3 over 3. Notice it says the exact value. So my clever friends who are like, well, I'm just going to type that in my calculator, put it in radian mode, and type 1 over tangent of 5 pi over 3. Okay, if you can figure out what rationalized decimal that is, then cool, good on you. I think it's quicker than to just do the formula. Okay. This question, again, it's walking you through how you're supposed to approach it. So it gives you some clues. It says the cosine is greater than 0, so you got a positive cosine. And then we have a negative sine. So what quadrant are you in if you have a positive cosine but a negative sine? So all students take calculus. It's down here, isn't it? So whatever this triangle looks like, it's over here. The clues about sine ratio being -7/25 will help me fill out this leg here and the r, the hypotenuse. And then I could do a little backwards Pythagorean theorem, or maybe I just know that that's the 7, 24, 25 triple. Is this a positive 24 or a negative 24 though? Positive, yes. Horizontal here is positive. So it says, what quadrant are you in? You're in quadrant 4. If you don't like Roman numerals, just write 4. And then you need to explain how do you know it's in quadrant 4. And it's going to be, you know, nothing really that great, guys. It's just, huh? Well, explanation, I'm looking for a sentence. So you're going to say, in quadrant 4, the sine value is negative. However, the cosine value is positive. That would be a good explanation. So now I want to know the tangent ratio. So tangent, we know, is opposite over adjacent, or y over r, which is the y over x, which is the fancier formula. So -7/24. The other thing I'm going to do before I move on from this problem is say, I was in quadrant 4, and I just gave my teacher a negative tangent value. Does that make sense to have a negative tangent in quadrant 4? And the answer is yes. Oh, everyone's favorite. Trig equations. So you're going to solve. You have to decide what approach you're taking based on what kind of function it is. Is this looking like a quadratic style function or a linear style function? And the fact that there's a squared in the problem, or there's more than one trig multiplied together, tells you it's a quadratic. So when we approach a quadratic in algebra, we look for factoring. I think we have the kind of factoring where you can take out a common term. Do you see a common term that both of these could be divided by? Cosine function. So if you factor out a cosine function, you still have 2 times cosine, and then cosine divided by cosine is still a 1. So we're undistributing the cosine, we're factoring it out. And now we're going to take terms equaling 0. So either this factor comes out to 0 or this factor comes out to 0. This one's ready to look at the unit circle. And for now, please just start on one rotation of the unit circle. Where on one rotation of the unit circle does cosine come out to 0? There should be 2 places. Yep, at pi/2 and 3 pi/2. Oops. And then over here, you got to do a little solving before you can look at the unit circle. So you're going to add the 1 and divide by 2. So this really says cosine coming out to a 1/2. There should be 2 places on the unit circle where you can find cosine coming out to a positive 1/2. Is it pi/3 and 5 pi/3? Okay. So because they want all solutions, there is absolutely nothing wrong with you guys going pi/2, oops, 3 pi/2, pi/3, and 5 pi/3, and then just sticking a plus 2 pi n on the end of each of these. That would be the I don't want to think about it approach. And you know what? I'm okay with that. However, one of these can be shortened a little bit. So these are all the solutions. But if you look at this one with pi/2 and 3 pi/2, that would be right here and right here. So these are really closely related to each other, except you're just rotating a half rotation each time. So another way to say these two solutions forever and ever and ever is to say pi/2 plus pi n. So if you didn't want to write these two out separately, you could swap this out for both of these. So that would be a little bit shorter. It's not that much better. All right, how much time do we have here? We can get one more done. Oh, let's get 2 more done. So these are think about it questions. Remember graphing trig functions? So this first one is going to be real funky. So if you're the kind of kid who relies on their graphing calculator to help you through all of these questions, 2 things are going to happen. You're going to run out of time on your test, and you are probably not going to get this one right because this one's weird. You have to understand what all this is asking. When I say what is the b value in your trig function, where am I supposed to be looking when they say the b value? It's like inside of the sine and cosine function as a coefficient. So this one doesn't have a phase shift, so it doesn't have to worry about factoring anything out. But the b value is this 3 pi/5 Gross. So then I have to remember something else about trig graphing, and that was how do you calculate period? So for a sine and cosine graph, the traditional period is 2 pi, but the b value changes the period, right? So you got to divide by the b value. So then, because we're pre-calc, we can't just have a normal problem. We got to have something like this. How do you divide by a fraction? Well, you don't. How are you going to change that? Yeah, you're going to change this to a multiply by the reciprocal of multiply by 5 over 3 pi. And finally, we're going to see some cancellation, and you get 10 over 3. That was funky. But you really have to know how to find those things in order to get it right. That's the point. This next one, they want to know about the phase shift. So phase shifts are very easy to identify if it's in factored form. So look closely at your cosine function. Is the b value factored out of the phase shift right now? Yes, it is. So your phase shift is staring at you if you can tell me how far and what direction it goes. So clearly it's a pi over 6, but what direction is that? Use your gut instinct. It's to the right. Very good. Phase shifts, when in transformational form, which ours are always in transformational form, have that built-in negative component. So x minus pi over 6 is a right pi over 6. All right, are we out of time then? Yeah, we don't have enough time to do any graphing. The next one up is going to be graphing. You guys remind me on Monday. This is where we left off. We are going to have plenty of time on Monday to answer any questions you might have. I'd like to focus on the post-test, though. So make sure you come up with, like, even if it's something we've already discussed on the packet, if you just say, hey, I want to see another example of linear velocity, like, we'll throw one together for you real quick, okay? All right, study, study. I will probably repost the videos from last year just because it's like in the entirety, like beginning to end. I'm sure they're awful, but whatever. Get what you get.